I'm so pleased to have you. I'm so glad to see you right here. Today, before I proceed, please don't forget to subscribe, like, and share my videos. You never can tell who you are helping. Today, we're going to be looking at something deep in integration under calculus, and that's integration area under curve. And I recall that I said I'll start making comprehensive videos on these things, but today I'll go deep a bit, then I'll give examples, and that'll be it for today. So stay back, just have a cup of tea while you watch this video. Right here, area under curve actually came from a two-dimensional axis. If this is yx, let's say you have a curve and there's a certain area under this. Now, this area, this is x, this is x1, x2, while this is the area, A. Now, the area under the curve is exactly what you see. This is the curve, and this is where the area lies. So right here, I can just vividly say that this is y equals integral x2, x1, then a in x. Please note that for the boundaries that you have, it runs from the bottom to the top, meaning the value you have at the bottom must be lower than what you have on top. Now, this is a very good and straightforward explanation based on area under curve. How do we spot questions on area under curve? Look at this. Example 1. Let's say you have a question like this, and this question is integrate 1 to 0, 2x plus 3, all into what? Dx. In one of my videos, when I talked about integration, I told you that the first thing you do is you integrate this. But write out this expression in full. This will be what? 2x. There's a 1 you cannot see. 1 plus 1 over 1 plus 1. Then plus 3x. There is a 0 here, which you cannot see because x plus 0 is 1. 0 plus 1 over what? 0 plus 1 plus what? C. Sorry, I train specially with some textbooks, so I majorly use it my constants. In JAM and some other examples, K. Now, if this is integrated, please, there is no need to put the integral sign. If you do, that means that you want to integrate again, which is not necessary. But for this, from here, I can say this is what? 2x raised power 2 over 2 plus 3x raised power 1 over 1 plus c. And this is what? 2x raised power 2 over 2 plus 3x plus c. So these two cancels these two. Now I've integrated that fine. Let me make use of my boundaries. So this will be what? X squared plus 3x plus c. Then this is what? 1 and 0. I tell my students something that seems to be very easy. Split this into 2. Why? Because change in x is the same thing as x2 minus x1. So this should be what? x2 plus 3x plus c. There is a 1 hanging minus, open bracket, x2 plus 3x plus c, and there's a 0 hanging, which is beautiful. What that means is, where you have x equal 1, where you have x equals 0. So that becomes 1 squared plus 3, 1 plus c minus into bracket 0 squared plus 3, 0 plus c. And this is 1 squared is 1 plus what? 3 plus c minus this is 0, this is 0, and of course you have the plus c there. So plus x minus is what? Minus. So this is 4 plus c minus c. C minus c is what? 0, and at the end of the day you have 4 units squared. Now quickly, because it is area and the unit for area can be in cm, millimeters, meters, inches, foot, and units. That's why you have 4 units squared. Thank you very much, guys. I'm so glad you've seen this. Please take your time and watch these over and over. You get it so quickly, and I'll see you in my next class. Bye.